Hello. In this tutorial, we are going to go to use the unit system and unit conversion in MATLAB. And we are going to apply this system and system unit conversion to solve this problem that is specified here in this slide. For this particular unit system and unit conversion, we are going to go to different MATLAB function, especially these ones specified here. And we are gonna, using these tools, we are gonna solve this problem. The first thing that we need to check to using this unit system and unit conversion functions is to see if we have the symbolic toolbox, unit symbolic toolbox in MATLAB. So in that case, we need to use this instruction in the command window and checking if we have installed. So let's do that in the MATLAB platform. So now we are in the MATLAB platform, and here in the command window, we can just place that particular instruction, which basically is called VIR there, symbolic in apostrophes, and enter. And basically it's give you some information. In this case, it's telling me my system, the symbolic math toolbox is installed. So I can use the different instructions that I'll address in a minute. Now, always remember that we need to check the help MATLAB instructions online that can be easily found. Especially in this case, I'm showing you like in the browser, the units and unit system list, where basically is listed all of the units that are available on MATLAB, including also some particular prefix and references. So please check that. We also have the unit conversion and unit system nomenclature here that is used that we are going to cover in a minute. We also have the unitConvert function, the separateUnit function, which basically is detailed explained in the help file. And finally, the VPA instruction, which is variable precision arithmetic, that are used for simplify mathematical functions on MATLAB. Now, let's come into MATLAB, and basically I have these example units that I'm gonna also share in the description so you can find it. And basically it's a live script that I have on MATLAB. So first is the description of the problem. So basically we have this manometer, U2, and has some mercury and oil. So they have the different specifications, and the idea is to obtain the density of the oil. So basically we know the solution here is pretty simple. So we have this point as a reference. So we have atmospheric pressure in both sides. So we have atmospheric pressure plus the height of the liquid in one side and the height of the other liquid in the other side with the respective densities. So we have atmospheric pressure in both sides. Gravity is the same. So solving for the density of the oil basically is equals to the density of the mercury, which is given, delta H, which basically is also given, and H1, which it's also given. So basically we have all of the information. So basically it's a simple problem where we can calculate the density of the oil. So basically here I'm placing different options. So the option one is the one that I recommended, basically is the longer option, but you can go step by step solving your problem. So first line, I'm just clearing all of the variables that are on the workspace. Second, and this is important, you need to create a symbolic unit called U. So basically I'm calling here the U as a symbolic unit. And this instruction must be placed at the beginning of your code when you are using symbolic units on MATLAB. So here, basically we have this one, and now we can come here to the list of the different units to basically find the units that we have. Usually they are pretty straightforward. So for example, in this case, meters is M, miles, MI, and so on. So you don't need to memorize them, but you need to make sure that you check the list, making sure that you are using the correct description of the unit. Coming back to MATLAB here, so we know that the H1 is in inches, 6.7 inches. So basically what I'm doing is putting the value 6.7 multiplied by the unit, in this case U, which is the indicative of the symbolic unit, and dot calling the units that we are going to do, which is in this case inch, indication from inches. So basically, I'm creating the H1 as a object and assigning to this 6.7 the units inches. After that, I'm using the command unitConvert to convert the H1 to, in this case, unit meters. So I'm converting to meters. And after that, with this VPA, I'm simplifying the expression to the respective dimension in meters. So let me just uncomment this one. And if I run this section, you're going to notice that the first part, I basically have the H1. So we have the units in inches. And after that, we have the units in meters when the unitConvert. And finally, with the VPA, we just simplify the problem. Now I'm converting the inches in meters. So if I have the semicolon here, I just don't show that one. But basically, I'm doing the same for the other dimensions. So delta H, which is the other the other given in the problem, it's in 1 centimeter. So I'm putting 1 multiplied by unit centimeter, converting to meters. And after that, simplifying. So basically, it's 0.01 meters in this case. So notice that I take in every variable and changing to international units or given or known units. Finally, we have the density of the mercury, which is in pounds over square feet. And in this case, we have the value. We are converting the units. For international units, we have kilograms over meter cubic. And in this case, I'm simplifying with 5 orders of magnitude. So basically, when I obtaining the density is this value in kilograms per meter cubic. And finally, I calculating the density of the oil, which is multiplying the density of the mercury, the delta H and H1, everything in international units. So when I'm multiplying all of these factors, I obtain the density of the oils in kilogram per meter square. In this case, approximately 800 kilograms per meter square. So with the next code, basically we are separating the units. So basically we can create a vector here of density rho that I call rho, and UN is units. So basically we are separating the value from the units and creating two values, density, rho, and units. But notice that these two are still objects. So if I want to convert the density in a number, basically I just put the double, like putting a double instruction. So basically I'm converting the density to number. So in this case is approximately 800, just a number instead of being a symbolic element. So that's the way that we can solve this problem. As you notice here, basically I went to the long way, which is taking every variable, changing the units of every variable, and after that applying the multiplication. Now in the option 2 is much faster, but basically it's the same structure. So basically we clean the variables. We create the U as a system of symbolic units, so the instruction must be there. So I specify every variable. Notice that I just leaving the units in inches, centimeters, and pounds foot cubic in the units that are given. And now I'm just multiplying using the formula all of the systems, and basically they are the system is keeping all of the units as they are given. They are not simplifying the units. Basically, they are keeping and multiplying the numbers. So after that, I'm creating a unitConvert function. And in that case, I'm changing everything to the units that I want, in this case, kilogram over meter cubic. And in that case, be simplifying my expression after using the VPA instruction. So basically the same result as before. And obviously, we can also separate the variables using the separateUnits function. And after double the data, basically we have numerical data. And finally, we have another option 3, which is basically similar to the previous one, but in this case, I'm using a different instruction for changing the units. So basically, in this case, again, we are defining the different units in the given units that are given by the problem. applying the multiplication. So we have the combination of all of the units. And here, instead of giving, as in the previous problem, the units that I want as an output, in the previous problem was kilogram over meter square, I'm just using the unitConvert, but I put in SI, which is System International, or International Units of System of Units, International System of Units. So if you put SI, basically it's transforming everything to international units, which density in this case is kilogram per meter square. So if you don't remember, you just use these units or this instruction. So it's automatically changing to the units that you want. And after that, also you can use the separate variables to obtain your final answer. So we have the three different options. Again, I recommend the option number one because you know what you are doing. So taking every variable and changing the dimension, the units first before operation. But also you can use the other different options. So as a summary, in this short tutorial, what we saw was how to use units, a system of units on MATLAB. Especially we explored these different functions in MATLAB to operate the system of units and units conversion. And using these functions, we did this example, which basically was calculate the density of the oil using this configuration. So you can check the code on the description, and please let me know any question. Thank you.